Okay, for today's class, welcoming everybody to class, of course. We're talking about what is the difference between experimental probability and theoretical probability. Okay, the difference between theoretical probability and experimental. So the first thing to write down, as the notes say, is what theoretical probability is. And that's what we have been doing thus far in the probability unit. What is expected to happen based on math, a model, or some analysis of the sample space. So when rolling a die, what is the probability that you land on your lucky number 5? Well, if it's a standard cubic die that we've been talking about recently in some of these problems, there are 6 outcomes, and one of which is the outcome, the 5, looking something like this. So you would say the theoretical probability is 1 out of 6. So if you want to think about this in different terms, that should happen one time out of every 6 trials. Every 6 times that you roll the die, you should land on that 5 outcome one time. Now, does that mean that is guaranteed to happen 1 out of every 6 times? And hopefully you're thinking, well, not necessarily, no. And that's what we're going to be getting into a little bit today and for the remainder of the unit. So think about this. How many times, what should happen? How many 5s should you get if you rolled the die 12 times? How many 5s should you land on? So if it's going to happen once out of every 6 trials, how many times should it happen out of 12 tries? Okay, and we have a simple proportion here. 12 times 1 is, of course, 12, and 6 times n is 6n, and hopefully you're noticing by now that n is going to be solved to be 2. It should happen twice out of every 12 tries, okay? So if I roll the dice 12 times, I should expect to land on my lucky number 5 twice. That's what theoretical probability is. In theory, this is what should happen, right? This is what is expected to happen, okay? Theoretical probability is what is expected to happen. But experimental probability is what actually does happen when an experiment is performed. So let's say I knew nothing at all about a die. I didn't know what shape it was. I didn't know the numbers on it. And I am just analyzing the die based on the stats of what happens. So I could set up an experiment and I'll just write down the results. And as I grow the sample space based on my results, then I can analyze the probability of the event that I'm looking for happening. And this gets used all the time in the real world. So let's actually see how many 5s do I get when I roll my die 12 times. Okay, I rolled it once. I am 0 for 1. I am 0 for 2. I am 0 for 3. 0 for 4. 1 out of 5. 2 out of 6. Or sorry, 1 out of 6. 1 out of 7. It's happened once out of 8 times. Once out of 9 times. Once out of 10 times. Once in 11 times. And 1 in 12 times. So experimentally, I have an experimental probability of 1 in 12. Experimental probability of landing on the 5. Experimental probability is 1 in 12. Okay? Now, this is if I knew nothing else about this die, can I conclude that if it didn't meet the expectation, does that mean that this die is broken somehow? And hopefully you are analyzing, no, this is not a rigged die. I mean, I guess it theoretically could be, but it does not mean that the die is broken. This is just simply the results of what has happened, and you can use the results of what has happened in the past to predict the future. And that's what experimental probability is. That's the moral of today's story. Right? So let's figure out what is the experimental probability of landing on red. Right? Let's assume that I cannot see the spinner and I cannot count. I'm just going to go ahead and perform an experiment. I'm going to spin it 8 times. How many times does it land on red? 0 for 1. Spin. 0 for 2. 0 out of 3. 0 out of 4, 0 out of 5. It has happened 1 time out of 6 trials. It has happened 2 times out of 7 trials. And it happened twice out of 8 times. 2 times out of 8. Okay, so experimentally, it was 2 out of 8. The experimental probability of landing on red right now is 2 out of 8, which reduces to 1 in 4, or in percentage land, hopefully you know that one, 25%. Okay, but is that the theoretical probability of landing on red? Remember, theoretical is based on the model. So theoretical probability of landing on red, I don't actually spin it. I actually just look at the sample space. I have 6 sections, 1, 2, 3, 4, 5, 6, and one of them is red. So the theoretical probability of red, this is a better pen. I should have been using this one the whole time. Theoretical probability of red is 1 in 6. Okay, 1 in 6, or 16.6%. Now, why doesn't my experiment match my theoretical? Well, just by happenstance, I happen to overperform the theoretical probability, right? Let's keep going with the spinner. What is the theoretical probability of landing on a cool color? That is a blue or a green, for all you people who know a little bit about the color wheel. Okay, theoretical probability, and I shouldn't perform the experiment yet. Theoretical probability is there are 2 that meet the constraint. There are 2 cool colors out of 6, and 2 out of 6 reduces to 1 in 3, or it should happen 33.3% of the time, or 1 out of every 3 spins is another way to say this. 1 out of every 3 spins, I should land on a cool color. Let's see what actually does happen. Let's spin it 8 times, performing the experiment. Okay, performing the experiment. It has happened 0 for 1. It has happened once out of 2 times. Once out of 3 times. I'm looking for blue or green, remember. Once out of 4 times. Once out of 5 times. 2 out of 6 times. 2 out of 7. And 2 out of 8. It happened 2 out of 8 times. All right, so our experimental probability just simply is the results of the experiment. It happened 2 out of 8 times, which is, once again, 1 in 4, or 25%. So what do you want to think about is, did the experiment overperform or underperform the theoretical? Okay, and hopefully remember, this is what is expected to happen. The probability of a cool color, P of cool, is equal to 33. It should happen 1 out of every 3 spins. We got pretty close to that, and 1 out of every 4 spins, or 25, but it underperformed just by a little. Okay, and that can happen. All right, so let's bring this into a little bit more of a sports application. The table below shows the free throw percentages for each UNC basketball starter a few seasons ago. Jackson shooting 76%. Barry the second is 83% free throw shooter. Meeks was 62% free throw shooter. And Pinson was 68%. And Hicks was shooting 80% of, making 80% of his free throws, right? So make a prediction. How many free throws would Isaiah Hicks make if he gets to actually go to the line 15 times? If he gets to go to the line 15 times, right? I'll pause the video. You do the same, and let's see if we get the same answer. Okay, so Isaiah Hicks is this person right here. So what we have to do is find 80. If he's making 80 out of 100 in experiment, okay, how many would you predict him to make out of every 15? Okay, essentially what we're doing is we are finding 80% of 15, right? And hopefully when you solve that proportion, you got 80 times 15 is equal to 100x. You're going to find 80% of 15 80% of 15 to be 12. You would expect him to make 12 of them. Right now, is this Isaiah Hicks guy, is he going to exactly hit 12 out of 15 every single time? No, not give or take. But we are using what has happened in the past, the experimental probability. We are using that to try to predict the future, right? And if you are the coach, suppose you are an opposing coach in the ACC. To give your team a chance at a late comeback, you must foul one of their players and hope the UNC player misses the free throw shots. And which UNC starter would you try to foul? Which would you try to foul if you're looking at these stats, which are very public? Okay. Hopefully you're looking at this and say, okay, based on the experimental probability, I'm going to take my chances on fouling Meeks. I forget what his first name is. Sorry, I'm not as good of a UNC basketball fan or any basketball fan as I should be, right? But based on what has happened in the past, he has the lowest experimental probability of making his free throws and scoring points against me. All right? So that is the difference between theoretical probability. Theoretical is what is supposed to happen, and experimental is using what has happened, what did happen to try to predict the future. Hope that helps, and that is it. That's our content. Don't forget to like and subscribe. Have a nice day.